This is the video that presents the solutions to your first test, the practice test. So the first question should be pretty straightforward. The derivative is given by 6 times 5, so 30x, drop 5 to 4, plus 2 times 3, which is 6x, drop 3 to 2, minus 7. The x becomes the power of 0, so it just disappears, and the 5 completely disappears. Okay, question B, when I look at this, I'd always want to convert the square root into power of a half. Likewise with this, I've got a fraction here, and these can actually cancel down if I think about how the index rules will work. So let's just rewrite this to start with as 5 on 2, just a single constant, x to the power of a half, plus 3 times x to the power of 1, x to the power of negative a half. Negative a half comes from the square root of x on the denominator position. And if I think about how that looks, 5 on 2, x to the half. If I use my index rules on this, I end up getting 3, and I add the two numbers together. 1 plus negative a half is just a half. X to the half. So really it's just 3 square root of x. So now if I find the derivative, then I bring my half down, so that ends up being 5 on 4, x to the negative a half, plus 3 on 2, x to the negative a half. And I'm happy to leave it like that. If you like, you could rewrite this as this, to the positive a half, or the square root of x. Same with this, 3 on 2 square root of x. Okay, the next question is a chain rule. It might be tempting to think that it's a product rule, but this is just a constant out the front, so we can just treat that just as a constant that can basically stay at the front. So the derivative will be, I'm looking at this, and this is my inside function here, and this is my outside function here. So I'm dealing with my outside function first, so the 6 comes down, times by half, it's 3. Middle stays the same. Drop my power from 6 to 5, and then I've got to multiply by the derivative of my inside function. So the derivative of 2x cubed is 6x squared, the derivative of 3x is just 3. And I'm done. Wouldn't worry about simplifying that at all. Okay, my last one is definitely a quotient rule. I've got a function on top of another function. I could try and simplify that to make it different. I think quotient rule is the way to go. I could put this on the top and make it a product rule. That's possible. If you did do that, you'll probably get a different looking answer to me. So don't stress too much. Okay, so if we think about what's going on here, I've got my u and my v. So my derivative will be the derivative of my top function, which is 1 on 2 root x. Just remember that this one here comes up all the time, so it's probably worth memorizing that fact, just to speed things up a little bit. Multiplied by the derivative, just my function at the bottom. Subtract my top function, left it as it is, multiplied by the derivative of my bottom function. Now my bottom function is a chain rule, isn't it? Got my inside function here, 2x squared minus 5, all to the power of 2. So I'm going to deal with my outside function first, which is 2, leave the inside, 2x squared minus 5, drop my power from 2 to 1, and then multiplied by the derivative of my inside function, which is 4x. And then I've got to divide by my bottom function here, squared, so 2x squared minus 5, which is squared, which would be to the power of 4, multiplied, not added.